Hello, algebra students. It is Mrs. Warren here, ready to take some notes. So let's go ahead and get started. It's our last week before winter break. Woohoo! So we are taking some algebra notes on 4.2 and 4.3 sections in your book, especially because 4.3 is very quick compared to 4.2. 4.2 is pretty long. So get ready to write. Intro to functions. Man, you guys, functions is one of the most important things in mathematics. You will spend the next many years studying different types of functions. In fact, the rest of our school year is only talking about different types of functions. So today's a pretty big deal. And today's like a transition time where we're going to transition into some really big meat of algebra. And I'm very excited about it. Functions are awesome. They're great. They're really important. But before we even define what a function is, let's just like talk about this fact, I guess you could say. Here's the deal, okay? There are values that depend on other values. Okay, I can wrap my head around that. There are things that depend on other things. You, as a person, depend on someone as an adolescent, and they have a relationship. I depend on my job to provide an income so that I can pay rent and buy food and so on and so forth. I depend on time for many, 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 many things, as you will see. Okay, so we depend on many things, depend on other things, which sounds really broad and general, I know. But let's kind of break that down a little bit more. So jumping into some vocabulary, we're going to unpack like this concept all day, forever, actually, the rest of the year. Okay, and so this vocab word that we're about to write down is really important. It's called a dependent variable. You may have heard of this variable in science. It's very important in science as well as math. Math and science go very close together, hand in hand. Okay, and a dependent variable is a variable that changes in response to another variable. For example, uh, growth changes it depends on time, growth over time, like your height or the growth of a plant. It depends on time. It's like hanging on to time. How much you get paid depends on how many hours you work. Okay, so there are these things that change, but they're very dependent on something else. Okay, and we see this also called an output. And remember, we're going to unpack this like crazy. In fact, I would encourage you right now to think about your own examples of what might be a dependent variable that you see. Now, dependent variable relies on what's called the independent variable. Being able to distinguish what is independent and what is dependent is very important, my dear class. Okay. But an independent variable changes without influence. So it doesn't depend on anything. For example, time. Time changes constantly. Would you agree? Like seconds tick away, minutes tick away, hours tick away, years, 2020, I know kind of feels like it has stood still, but it really has. Time has changed, okay? And it doesn't depend on anything else. Nothing else affects time, yet it still changes. We call this our input. And again, we'll unpack that for months and months ahead of us. Okay, but these two phrases are very important for us to really grasp. So let's just really look at an example here. Let's talk about height and time. Our height depends on our age, which is a form of time. If you didn't know that, age is a form of time. So this would be our independent variable, and our height would be our dependent. So again, I encourage you to pause this and think about another example of height or of independent and dependent. What else around you might be independent and dependent? You can even Google it and look for examples of independent and dependent variables. I'm sure there's lots of cool things that show up. But I encourage you to kind of think about that before you press play and move on again. Or you might just decide to move on with me, and that's fine as well. Okay, so another kind of note here before we jump into an example. I know I'm going kind of fast. That's because we have a lot to cover in a very short amount of time. But we can represent these values using a lot of different ways to represent it. Okay, so I'm going to make a bulleted list here. We can use t-tables. If you don't remember what a t-table is, we're going to look at it here in a few minutes. We could use words. How we've seen it already. We could use equations. We're going to see a lot of that. We could use sets of ordered pairs. Now, if you don't remember what an ordered pair is, please pause and go Google it right now, because you need to know what an ordered pair is. There's no shame in Googling it. And graphs, which BT dubs, you can't graph without an ordered pair. Because we're talking about X and Y axis, not just the X axis that we've seen so far. Okay, so let's just kind of unpack an example of this type of relationship. Okay, so in words, let's say Josiah, that's the name I thought of. That's my brother's name. I don't know why. His birthday's soon. Maybe that's why. Josiah earns $15 per hour. And he probably earns more than that, actually, but he's not watching this. Okay, so let's unpack this. This is a relationship. Would you guys agree? Money, you earn money based on how many hours you work. Those are two different variables that change. And in fact, let's actually even unpack it even further. Let's say what the independent and dependent variables are. What's not changing? Time. So the hours. Or I shouldn't say what's not changing. It is changing. Like how many hours he works does change. But in the context of this problem, his money, like how much he earns, depends on how many hours he works. So dependent is money. And if you ever are struggling trying to figure out which one's the independent and which one's the dependent, ask yourself this question. What variable is doing the depending? Because you could get into like an existential crisis here if you think too hard about it. Because you might be like, he does control how many hours he works. Well, that might be true, but that's not the relationship we're looking at. We're looking at how much he earns based on the hours he works. And how much he earns depends on the number of hours. So be careful when you are deciding what your independent and dependent are. Okay, but here's a cool thing about this. So this is in words, right? Cool, words representing this relationship. You guys, we can actually also use an equation to represent this. Newsflash, we have two variables now instead of one. We've only had one so far. And our dependent is always the y, and our independent is always the x. That will always be true. I hope you heard that. Independent is the x, y is the dependent. This is very important. So let's think about what our equation would be, you guys. Well, if y is how much he earns, that's equal to 15 times however many hours, right? X is the hours, Y is the cost. Again, we're going to spend so many months working on this, so many months. So I can represent this using an equation. Can also use a t-table. Be kind of cool. Let's look at that. X and Y, X always goes on the left. It is our independent, and Y is on the right. And a t-table comes from our like gut. So we choose our numbers and our X on our own. They're not given to us like they have been in the past. So for instance, what if I'm curious, like, oh, if Josiah works 0 hours, how much money will he make? Oh, $0. Cool. What if he works 1 hour? How much money will he make? Oh, 15. It's pretty logical, Mrs. Warren. If he works 2 hours, how much money would he make? Well, $30. And in theory, I could keep going forever. But I don't have time for that. Neither do you. So again, you're seeing X is the hours, Y is the cost. Seeing that relationship, it's so important. Ooh, I forgot to change my background. I gotta do that real quick. To graph paper. Look at that. And here, oh, Mrs. Warren, that is the most pathetic line. I know, guys. Let's see if I can change it to better graph paper. Hold on. Let's go with this. Yeah, that's a little bit better. No, where'd it go? Come back. Oh, it undid. I hit undo and it undid my graph paper. Okay, so let's see if I can do this better. Oh my heavens. Okay, we'll go this way first. That was easier for me on this. Also, I just need an orange, fun fact. So my hands are kind of sticky, which makes the like drawing a line on here so difficult. Well, I hope you all draw a better line than me. Cool. Okay, so X, Y. Newsflash, these are actually called ordered pairs. That's an ordered pair, so if you didn't look it up, I just helped you. And that's what we graph. X is always first and Y is always second. And so my first point here is 0, 0, and my really straight line I drew. You guys should totally use rulers if you have them, or a straight edge. I'm going to go up by 15s because I know he makes $15 an hour. And then I'm going to go up by ones on the x-axis because I'm just looking up for 1 hour. So 0 hours, he earns $0. 1 hour, he earns 15, and 2 hours, he earns $30. And look at that, you guys, another line that I get to draw. Oh my gosh, I'm so excited. But notice that I didn't figure out all the hours. Like, this is probably doesn't make sense. Like, works negative hours, probably don't need that, but I could keep going on and on and on forever. 7th grade, we called this a proportional relationship. If you remember, I know if you were in my class, we talked so much about it. That was like one of our last things before we left for the pandemic. Okay, so like pretty cool. If you look at this, like one concept we can represent mathematically many different ways. Okay, now here's where it all comes together, and it's pretty cool. All of this is called a function. This example can be seen as a function. This is a magical word in math, you guys. Magical word. Function. So I suppose the next step would be to define what a function is. Also, I'm home alone talking to myself on camera, and so that's why I get a little bit silly. So bear with me. I'm alone in the world. There's no one here. That's not true. My husband's just at Starbucks. Okay, let's talk about what a function is. A function. You guys, I cannot stress to you how important it is that you know this word at any point for the rest of your life. If I'm like, hey, you, remind me what a function is that you learned in 8th grade with Mrs. Warren, you should be like, oh, it's this. That's how familiar we need to be with this word. So here it is, a relationship, which we just saw. We're not talking about like boyfriends and girlfriends and parents and siblings. We're not talking about those kind of relationships, although those are important. We're talking about math relationships. Okay, so a relationship that pairs each input value, which we wrote above, input value, with, and this is a very important word I'm about to write, exactly one output value. Mrs. Warren, what does that mean? Here's what it means. If I work for 1 hour, I'm only going to earn $15 based on that example. I work 1 hour, there will never be another amount of money I will earn for this example. In other words, we call this 1, 2, 1. So if I'm like, hey, Rachel, if I see her like in 2 years and I'm like, hey, Rachel, what's a function? She would be like, Mrs. Warren, it's 1 to 1. Like that's what I expect you guys to say. Now, what does 1 to 1 mean? Let's kind of unpack that. All right. Let's view a function machine. What is that? Well, let me draw it for you. This is like my infamous drawing. I draw this every year. And it's something else, let me tell you. Okay. Kind of view this here as a machine. I didn't mean to do that. Okay. And up here is my input, and it's where I put things into my function machine. And here is my function. And out of my function comes something new. So for example, let's say my function is y equals 15x. That is my function. When I put the number 1 literally into my function, then the number 15 comes out. If I were to put the number 1 in again, would any other number but 15 come out of my function machine? The answer is no. It would still be 15. This is an example of 1 to 1. If I put in the number 2, then the number 30 comes out. If I put in the number 3, the number 45 comes out. There will always be one unique x value with one unique y value. This is a very important concept to understand. In fact, it's so important that I have a famous video I show every single year. This is my 10th year showing this video. Unfortunately, we cannot watch it together in class, which is such a bummer, but I would like you either pause this video right now and go watch it. It's also posted on our Canvas page, or at the end of this lesson, at the end of notes, go and watch that video. It is infamous. I want to warn you, if you have had a pet die recently, it could be a little traumatic. And that might sound so weird, and I know I'm recorded for saying that, but you will see after you watch it. I have a very funny story to tell you about that tomorrow in class. Make sure to remind me. This is kind of like your hook to come tomorrow. It's funny and a sad story and very embarrassing on my part, but I promise you I will tell it to you. So right now would be the time to watch the famous video. I have had 3 previous algebra students ask me for this link this year alone. That's how famous it is. I did not make it. The credit does not go to me. So go ahead and pause now, go watch it, or watch it at the end of this, up to you. Either way, we are going to unpack what a function looks like versus a non-function. And we're not going to do a whole lot of examples in our notes today just because there is so much info to just write. And so what I want to show you though here is a little t-table. Man, my lines are just getting worse. And we're going to use the same exact function we saw earlier, which was y equals 15x. And we saw the graph as well. I'm just drawing like super fast sketches here. Although that line was better, I will say. Good job, Mrs. Warren. Thank you, guys. And our graph looks something like this. 1, 2, 15, 30. If you need help graphing, let me know. You've got to figure that out here in algebra, like ASAP, because we're going to graph a ton. Okay, all of this is a function because it's 1 to 1. Here's an example of something that is not a function. You can still write a t-table for anything in math, okay? But here is something that is not a function. Notice I've written everything the same, and then all of a sudden, something happened. Do you see this? There is one x that goes to 2 different values. It is not a unique value for y. So this right here is not a function. It is still mathematically sound. In fact, it's called a relation, but it is not a function. What would the graph of this look like? Let's look at a visual. I actually don't know what the equation would be for this, you guys, so we're just not gonna. So let's look at this, what this graph would look like. So let's use a different color. Let's use white. I'm going to keep things the same here. 1, 2, 3, 15, 30, 45. I forgot my arrows on the end of this graph. Those are absolutely necessary because my line goes on forever. It's the definition of a line. Okay, so let's graph this. 115, 230. Uh-oh. Look what happens. Here's, for my visual people out there, look at this. At 1, I have 2 x's. This is not possible. In fact, I don't even know how I would graph this, like something like this, I guess. At 1, at the number 1, I have 2 x's, and that is not possible. That is not 1 to 1. This is 1 to 1. Because if I were to put 1 here again, guess what? 15 would come out of my function. All right? And you will unpack this a little bit in your homework tonight. There's so many examples of what a function and non-function is, but for the sake of time, I'm going to keep going. There are so many videos. I was going to just find a video already made and send it to you, but there's literally so many out there. I couldn't decide on one, so I thought, you know what? I can just do this. Okay, so really the meat of your homework is being able to graph and identify a linear function, which let's define it. It is a function still. That is a non-vertical line. English, Mrs. Warren. I can do this. A function that is a non-vertical line. Okay, so boop, right there. That would be a linear function because it is a line. It's just not vertical, like straight up and down, if you didn't know what vertical meant. And then a non-linear function. Okay, here's what's crazy. You can have something that's not a line and still be a function, and I'll show you it's pretty legit. But you guys, functions, these are so important. Okay, it's a function that's not a line. Ah, wow. I'll show you some examples. We're actually going to study a nonlinear function really in depth in chapter 9 this year. We're in chapter 4. When we get to chapter 9, we are going to very much study what's called a parabola, which might sound like a crazy word, but we are going to. So look at this. This is called a parabola. You don't need to really remember that right now. But this is a function. This is a non-linear function. It is still 1 to 1, and I'll show you why. If I were to make a t-table of this and have, let's use these points right here. So that's -2, 0, and 2. You would see that this looks like 2, this looks like 1/2, and this looks like 2 again. Okay, you would see that even though the y is duplicated here, see how there's 2 2's in the y column? That doesn't matter because all we care about is it being 1 to 1 with the x's. There has to be 1 x to 1 y, and there's no repetition with the x's here. So this is a function. Okay, so that's actually all I have for you right now. We're going to unpack this more tomorrow, but you do have a homework assignment in Pearson. Savvis, whatever you want to call it. It's your online virtual assignment. Use the show me extra help, use the videos, reach out to me if you have questions, watch the famous video. And like I said, we're going to spend a long time on this. It's new. We're going to get better at it as time goes on. And just keep it up, guys. All right. Happy watching.